Okay, this is example 3. It's from 4.2 and it's on page 223. Okay, and it says determine the roots of each quadratic equation and verify your solution. So I'm going to take my quadratic equation. Okay, 1 second. I'm going to orient this because it's wicked off. Okay, so a equals x squared plus 6x plus 9 equals 0. Okay, now if you're really on the ball, you're probably going to recognize that as a trinomial square, right? Because we have a perfect square here, that's x squared. Perfect square here, which is 3 squared, okay? And this middle term is 2 times 3 times x, right? So you know that's a trinomial square, and then you know that you would take the x, and you take the 3, okay? So it would become x plus 3 squared, right? So if you recognize that, it's pretty quick. You're just going to say this is x plus 3 squared, or x plus 3 times x plus 3, which would give you roots of whatever you get when you set that equal to 0. Okay, so you have x equals negative 3 as a root. Now, of course, if you didn't recognize right away that that was a trinomial square, that's totally fine. You would just look for two numbers that add to give you 6 and multiply to give you 9. And as you started working through the factors of 9, and we're looking for positive ones here, it wouldn't take you that long to find that 1 and 9 don't add up to 6, but 3 and 3 do. Okay, so you can do it that way as well. And then you would know that it's you would probably write it as x plus 3 times x plus 3. And then you would rewrite it as x plus 3 squared. And then you might think to yourself, oh, I should have recognized that as a trinomial square. But whatever. You could do it either way. It doesn't matter. It's nice to know that that is a trinomial square, especially when we're working with completing the square, because those are so important. Okay, but if you miss that, that's okay. All right, this one here, x squared plus 4x plus 21. Okay, not a perfect square. You know that because 21 is not a perfect square. All right, and so we're going to be looking for two numbers that are going to add to give us that middle coefficient, 4, and multiply to give us positive 21. Sorry, I don't know why I put a negative there. Okay, now 21 does not have that many factors, right? It must be a negative 21. I think I copied it wrong, didn't I? Yeah, sorry, it is negative. I wrote it wrong there. Okay, and I knew that because if I had positive factors, they wouldn't add up to 4, right? So I caught that mistake that way. Negative 21 does not have that many factors. Okay, it basically has 1 and negative 21, negative 1 and 21, 3 and negative 7, negative 3 and 7, right? So the two that are going to add up to positive 4 are negative 3 and 7. Okay? And so I know that my factors are going to be x minus 3, x plus 7. Okay? And so in order to find my roots, okay, lots of people like to do this in their head, but you don't have to. X minus 3 equals 0, so x equals 3. Okay? And then x plus 7 equals 0, and x equals negative 7. And the reason why I set each of those equal to 0 is because of the zero product property. And the zero product property tells me that if I want this factored equation to be 0, then I just have to make one of the factors equal 0, okay? Because 0 times any other number is 0. So if I can set x equal to 3, this factor becomes 0 and the whole thing is 0, okay? And the same way, if I set x equal to negative 7, then this becomes 0 and the whole thing is 0, okay? And then C says 2x squared minus 9x minus 5. Okay, so if you're good at factoring, you might want to try to do this one by kind of a trial and error, guess and check type thing, okay? And so that's not a bad one because I know that I got my first term by multiplying a 2x by an x, definitely, right? That's the only two things that could be multiplying together to give me 2x squared, okay? And obviously I got that 5 there by multiplying a 5 and a 1, okay? And so I can try a few different things, okay? I'm going to either put the 5 here and the 1 here, or they're going to be in the opposite, okay? So if I take a look at these, one of them has to be positive, one has to be negative. So if I'm looking at, say, a negative 5x and a positive 2x, okay? Or even if I switch the signs, I'm looking at something about 3, okay, which isn't going to work. Let's put the 5 over here, because then the 5 will multiply with the 2 to give me 10. and the 1 multiplies with the x to give me 1, which those two are separated by 9, okay? And I want the 10 to be the one that's negative, okay? So I can do it that way, and then you can kind of check it at the end. Okay, that's a little quicker, or you can go through the whole process, the whole systematic process. You can say, I need to multiply the first coefficient and the coefficient of the x squared term and the constant term together. That's going to give me negative 10. Okay, so I'm looking for two numbers that will multiply to give me negative 10 and add to give me negative 9. Okay, so that's not a tough part, right? Because that's going to be, let's look at the factors of negative 10. We got 1 and negative 10. I'm just going to stop right there, right? Because that's actually what I need. I need a 1 and a negative 10. 1, negative 10, okay? And so I'm just going to replace my middle term here. Just going to kind of decompose that middle term into negative 10x and positive 1x. Okay, it just suddenly occurred to me that it was a good idea to put that, to actually write that one in, because then you can see that that's something that you could take out, right? So normally I wouldn't write that, but it's actually not a bad idea in this method. So I'm going to factor by grouping when I have these four terms, right? That's the next step in this decomposition. I'm going to take the 2x out. That leaves me with x minus 5, okay? And then in the next two terms, my greatest common factor, I'm going to have to take something out, so I take out a 1, leaving me with x minus 5 again. Okay, so 2x plus 1 times x minus 5 equals 0. Okay, if you're ever unsure, you can always just multiply back and check. Okay, and you can also, you got to get these two, they have to be the same or you've made a mistake, right? So sometimes if the sign's different or whatever, people make mistakes there and they get one is x plus 5 and one is x minus 5. If that happens, you haven't done it properly. Okay, you need to go back and find your mistake. Okay, so according to the zero product property, we'll get our roots, whatever makes these factors 0 are our roots. Okay, so you can just solve them. So x equals negative 1/2. That's what would make the first factor 0. Okay, and what would make the second factor 0 is x equals 5. Okay, so those are the two roots of that equation.